Hey, g'day, it's Presser. Thanks for stopping by. I hope you're doing well. Now, today's video is all about finishing a project that I've been working on for the last couple of months. Now, it's this beautiful float lock vise. Now, a float lock vise is an accessory that goes on your drill press and it allows you to hold work down securely, but it's very quick to set up and very easy to use. Now, I literally finished this project yesterday, and then I immediately want now to break it down and actually do all of the metal finishing processes on it. So by that I mean I want to put protective coatings on some of the parts, like the aluminium castings. I want them to be powder coated. I want the machined aluminium parts to be anodized because that prolongs the surface finish, makes it harder and tougher in terms of wear. And on the steel surfaces I want to prepare them in a way that keeps corrosion at bay. So I'll be using a process called Parkerising. So that's all coming up, and it's really is just an overview of all of those processes because I've done them in more detail in previous videos on this channel. And I'll put a link up above there now to a playlist called Metal Finishing with Mark, and in those videos I went into a lot more detail about how to do each of these operations. But first of all, got some new stickers, so I'll get them up on the door and we'll talk about the owners. Our first sticker today comes from a gentleman named Chris. Now, Chris lives in Roanoke, Virginia in the United States. Now, he has a home workshop, looking to grow his channel, and here's his home page on his YouTube channel. And when I was looking through that, I noticed that we have these sort of common intersecting interests. And for example, he loves touch DRO, as do I, one of my favorite tools to use on my milling machine. And he also recently made a DRO for the tailstock on his mini lathe. Now, that was also a project that I've been working on, but Chris went about it in a slightly different way to what I did. And both channels I'll show you today, we sort of have these common interests, which is a good thing. So let's get this one up on the door. I always sort of worry that I'm going to get these things crooked. It's really hard to stand off to the side and check to make sure you got them straight. Alright, so there's Chris. Still not sure what F&A right means. I'm not sure if that's an acronym or whatever, but anyway, Chris. So this next one comes from the UK now. It belongs to Andy and Michelle, and they sent me this lovely card, and this is Michelle's own artwork. So she's an excellent and capable graphic designer and artist, and these cards are just beautiful. But their workshop is more to do with model engineering, and I say their workshop because when I checked the homepage on the YouTube channel, it appears that Michelle appears in just about every video, and I understand that Andy's a bit reluctant to be seen on camera. So his lovely wife does all of the commentary, all the explanations to camera, and I think that's great. I mean, I take up parts that I show to my wife in the evening. I can be down here all day, make a complex part with internal splines and excellent attention to detail. I'll be very proud of it, and I'll show her, and she'll say, "That's nice, dear." Anyway, let's get this one up on the door. Alright, let's put this one down here. I'm rapidly running out of room on this door. We're starting to get down close to the floor. So I might have to spread to another door soon. There it is, checking both out. Like I say, there's some excellent work and I'd love to see their channels grow. Now, if you're wondering about my t-shirt today, this came all the way from a place called Friedrichshafen. Now, it's in southern Germany. It's right on the shores of Lake Constance, and known locally as Bodensee. And it turns out that Friedrichshafen is the home of the original manufacturing plant to make Zeppelin airships. And there's an excellent museum there that we were able to go to. They have historical artifacts and original parts from Zeppelin airships. And there's also a mock-up of the interior accommodation units from the Zeppelins. And it turns out that all of the furniture that was made for those units was specifically designed for lightweight. So a lot of the parts made of aluminium, lightweight plastics and wood, and the walls of those interior units were made of silk, but they were painted to look like wallpaper. And the next morning when we were driving on to our next destination, we actually saw an airship flying around because the original airbase and the hangars are still there. And Zeppelin still make inflatable airships, and it was very, very cool to see that flying around as we drove off. So that's it, that's my t-shirt for today, but let's get on to the float lock vise project. Since you saw this last, I've made some upgrades and improvements, so let's have a look at each one in turn and then we'll break this down and start doing metal finishing. So the first upgrade is this clamping screw here, and the original one that you would have seen probably in the last episode looked like that, and it put the Tommy bar very close to the top surface of this clamping block, and when you went to tighten it your fingers sort of got trapped underneath and it wasn't very pleasant. So putting this up higher just is much easier to grip and use, and I put a big generous radius on the top of that screw there. The original one just had a big chamfer. And I did this on the Tornado radius turning attachment on my Colchester lathe. Now, I absolutely love this tool. It works a treat on mild steel, even though when I bought it I understood that it was only for use on materials like brass, plastic and aluminium, but does actually work perfectly on steel. So that's the first one. The Tommy bar is now much easier to grip and to use. Now, the next upgrade here was to put a generous 3/16 radius on all of the sharp corners and edges on these two halves of the clamping block. Now, in the previous episode these all had sharp corners and edges. I had intended to do something like put a chamfer on them, but I ended up putting a really nice radius on that corner there. Now, I had seen Tom Lipton doing something like this, and also a gentleman named Bob Thomas 52 who I follow on Instagram, and he's truly a master machinist, but he showed using an ordinary wood router bit to put a corner radius on cast iron. I had this one here. This has been used previously on wood. It's got a 1/4 inch shank on it, and it's just a cheap generic one, and it worked absolutely perfectly. So here's some footage of me doing this on the Bridgeport, and I took cuts of around about 1/2 millimeter to around about 1 millimeter deep, depending on whether I was just starting on the sharp corner or finishing the cut where the chip was wider, and I ran it at 800 RPM with a bit of coolant or cutting oil, and no one was more surprised than I at how well that worked. So there you go, you can cut steel with these things and it works perfectly. Now, in the original float lock vise drawings that I downloaded from the internet, it showed that there were 2 fixturing holes in this ratchet jaw here. At the time I couldn't figure out why you would need them or how they would be useful, and then just yesterday I realised I had to make 44 of these little plastic parts. Now, these are made from that composite decking material. It's for use in an outdoor application, and each one has to have 2 holes drilled in that pocket there. And I thought about setting it up on the Bridgeport and using the DRO. Then I realised that it didn't need to be that accurate, and I can do it on the float lock vise. So what I've done is I've made a little adjustable end stop here, so it can be slid along the full length of that slot there. You can move it from one screw hole to the other. You can flip it end for end, and it allows you to cover pretty much, well, all of the length of yours plus a bit extra on either end. So I could set that in position and then put my part against that end stop, and you don't even need to really tighten the jaws that much. So with it in that position there, you clamp the vise down, go ahead and drill your first hole, and then either move the vise or move the stop and then drill the second set of holes. So that's a real game changer if you're making multiple parts and you want them to be, you know, semi-accurate. Now, in the drawings for this, and I am making the drawings available in this episode of the build, there's a link in the description to my Dropbox, and you can download a folder that has all of the 2D drawings. It's got the STL files for the patterns for the jaws. It's got some other information, the original patent drawings that I found on the internet and so on. So all of that's there. Check it out. You can download it for free. It's yours to keep. And I've included this little package here. So I've got the stop and the position of these 2 screw holes. So yeah, brilliant idea, not mine, but I realised now that those fixture holes were important. In the last episode I had a bit of a rant about this handle here, and I was sort of suggesting that it's going to take some getting used to, and one of the reasons is that you can really only get half a turn before it sort of fouls on the surface of the table. So to move it a lot, you've got to sort of keep swinging the handle like that, and I said that, you know, it's going to take some getting used to. Now, lots of people in the comments suggested that I fit a ratchet mechanism here or some sort of a universal joint or use a hex socket to tighten and loosen it. But the solution is much simpler. Now again, thanks to the people in the comments for pointing this out. There must be a lot of people who own these who've worked this out. But the workflow for tightening it is not to try and do it here, but actually to move the whole clamp out to the edge of the table. So slide it out to there, lock it, do whatever you need to do, tighten it, loosen it, whatever, and then move it back again once you've got it clamped. So that's tight there now, and it just comes back to wherever you need it on the surface of the drill press table. So again, thanks very much. Old dumbass here probably would have worked it out eventually, but getting that information in the comments sort of made it much easier, and I don't have to modify anything. Now finally, I copped a lot of heat about this clamping arrangement here, and a lot of people suggested that I did it wrong. When I drilled that hole, I put it at a 0.6 degree incline to the surface of this clamping block down here. Some people said I inclined it the wrong way. I honestly don't believe that's true. I've checked and rechecked. Sure, I did it correctly, but you would have noticed that when I first tightened this down, there was a gap underneath the vise here. Now, I have corrected it. It does work now, and according to Blondie Hacks, this is the standard test. So what you do is you loosen the clamp, you slide a piece of paper underneath, tighten the clamp back down again, and you should not be able to pull the paper out. So that, I'll tear the paper if I keep going. So that's actually gripping really tightly against the surface of the table. So there you go, it passes the standard paper test. So here are all the parts now broken down, and I've grouped these according to the sort of surface finish that we'll be doing. So all of the steel parts on this side will get Parkerized. These three parts here will get powder coated. The steel jaws are going to come off shortly. They will also get Parkerized. And this little aluminium part here is going to get anodized. All the fasteners get cleaned and put back as they are. So let's get these jaws off now, and we'll start doing all the surface prep. For these steel jaws, these were made of hot rolled steel, so they had a black oxide layer or a mill scale on them. And to remove that, I use vinegar. It sort of takes overnight to remove that mill scale layer, but then you get an underlying steel surface which is fairly easy to clean up with the abrasives. Now the workflow of cleaning up these parts prior to any metal finishing is always to check the surfaces and edges and corners for defects and damage. That can be removed with files, and from there we can go on to my, well, it's a poor man's surface grinder really. So it's just an abrasive belt stretched out over the surface of my saw table, and from there we can work on the surfaces, just rubbing them over the grit until we can check that surface and see that all of the machining marks are gone. Now for edges and corners, I can do that with a Dremel, just with a small drum sander, just sweeping that backwards and forwards until you get a decent sort of chamfer on those corners and edges. With the steel jaws, I'm using quite a coarse belt here because this is the surface that had the mill scale on it, and it's quite pitted underneath that mill scale there. Now, not sure if it's worth going to too much trouble with these because it is the face of the jaw, but on these other parts, like this little stop here, I've gone to a lot more trouble. I've used a fine belt with this, and this will be quite visible on top of the clamp, so I want that to look good. As it turns out though, you can get a super bright grain finish on that, but by the time you parkerize that, it's going to look quite different, and I'll show you what it looks like later on. So those parts now are nice and clean on the outside, and these silicone rubber plugs here just to keep the grit out of the bore in the casting. Now try not to touch these now. These need to go in the ultrasonic cleaner along with all of the other parts, just to ensure that there's no grease or oil in any of the threaded holes, and then from there we'll do the powder coating on these. But yeah, that sandblasted finish makes the powder coat stick like crazy. I just left this casting on the bench for a while after I've sandblasted it, and you can see a problem there. So there's some porosity in this casting, and during the machining process it's absorbed some oil, and now it's starting to bleed out onto the surface. Now if you don't do anything about that, the powder coat won't really adhere in that area, and it'll leave pinholes and bubbles in the surface. So I'm going to put this in a really hot oven and try to dry off or burn out that oil. And then we'll also do it in the ultrasonic cleaner. I'll just put the 3 castings into a bag of simple green cleaner, and this goes into the ultrasonic. We'll run that for about 10 or 15 minutes. The idea of putting it in the bag is so you don't have to waste so much of the cleaner in the ultrasonic tank. So you need just enough to cover the parts. So I'll give that, I'll give it 15. So this is the bag that came out of the ultrasonic cleaner. You can tell by the colour of that cleaning fluid that there's a lot of contaminants in there. I think this is the one that had the porosity on the surface, but I'll rinse this one off. If there's any water breaks on the surface there, it means that there's still oil coming out of that material. That looks slick all over, so I think we've got rid of the oil, but I'll put this back in the oven to dry it off and then we'll powder coat it. You might notice there it looks a bit patchy sometimes when you first start, and what I'll often do is just zap it with the end of the gun, and that seems to put a static charge into the part, and then it accepts the powder a lot better after that. Also the powder builds up and that attracts more powder to the surface. So I'll just flip that around, give it a bit more, and get that one in the oven. Sometimes you've got to be a bit strategic about where you wire these things. So I've jammed the wire in with the silicone plug here because this undersurface is going to get covered anyway. So if I get a little bare patch where the wire goes in, it won't matter. Okay, that's got plenty on it. That goes in the oven. Okay, that one's done. Alright, last one done. So here's all our steel parts now. We're going to take these through each step in the Parkerising process. Now I'm just going to show you very briefly. If you want more detail on this process, I've done a dedicated video on Parkerising. The link's up above there now. And all I've done to this point is I've sanded the surfaces to make sure there's no machining marks in them. And what we're going to do now is put them through the ultrasonic cleaner. We'll do that in batches. And it doesn't matter what sort of metal finishing process you're doing, that's usually the first step. So it doesn't matter whether it's anodizing or zinc plating or parkerizing, you have to start with super clean metal. Okay, we'll rinse these, do a water break test. So what you should see at this point is that the water just runs off, there shouldn't be any beading, and it should look slick all over. So these are good, so now we're going to activate these. Got all the parts wired on copper wire now, and they've been in a bucket of cold clean water, and now they go into this activator. It's called Metex M, but it's basically just an acid, and it activates the surface so that it will take the Parker phosphate coating more easily. So we'll leave them in for around about a minute to a minute and a half. While that Metex M is doing its magic, there's a stream of very fine bubbles coming off the part, so you know it's actually working. Okay, these come out now and they go into a cold water rinse. Okay, these parts get swilled in clean water, and from there they go into a pot of boiling water. They'll sit in there for about 1 minute just to preheat the steel parts. Okay, 1 minute's up, so these are going to come out now and they go straight into the Parker phosphate solution. It's heated to around about 95 degrees centigrade. You don't want it boiling, it just evaporates off all the water in the solution. Now, if everything's happening correctly, you should see a stream of bubbles coming off that part immediately, and then we leave that in there for about 15 minutes. After about 3 or 4 minutes, you can see the surface is now quite black, and we get a good thick coating if we leave that in there for around about 10 minutes, but 15 is probably maximum. So this is one of the parts I put in first, and it stopped fizzing. That usually tells you that the process is done. This comes out now, gets a cold water rinse, and then it goes into a soluble oil which will absorb into that coating. Okay, that's rinsed clean. Now it goes into the hot oil. This is called a dry touch oil. It's just soluble oil based on water, and it's heated up to about 50 to 60 degrees C. And these parts are just sitting there for about, I don't know, like 10 minutes. Probably just dunking them for a couple of minutes would be fine. I'll probably leave it in there until the whole batch of parts is done. Okay, they're done. Just going to hang these up now to dry overnight. So the water component in that soluble oil will dry off now, and it leaves behind an oil film. The oil film is impregnating the porous coating made by the Parker phosphate, and it leaves that charcoal grey colour. It's highly corrosion resistant, in my workshop anyway, and it's got this unusual sort of sandy texture to it. So I'll leave that overnight. While we're waiting for those Parkerized parts to dry, I'll go ahead and anodize this part here. So again, the process always starts with making sure the material is super clean. I'll do that in the ultrasonic cleaner. I'll anodize this in black, and that will toughen the surface of this part and it'll protect it from wear and tear. You do need to rinse these parts really well at every single step. And the other thing that's essential here is that you get a piece of aluminium wire, make sure it's jammed into a threaded hole or some other opening or some way of attaching it electrically, and it's really got to be attached well. Just hanging it on a hook is usually not good enough. So that's quite solid there now, but I'll give that another rinse. So just remember, lots and lots of water. Now that I have that part attached to the wire, I'm going to put this into an aluminium brightener. Now I think this is just a dilute nitric acid. but this will just remove any surface oxide that's still on the part. Those oxides form on aluminium almost instantly, and then we'll give it another really good rinse, and then it goes in the anodising bath. Okay, we'll give that maybe an hour and a half, 2 hours at 15 volts. I've set the power supply to 0.4 of an amp, but it's only taking about 0.12 at this stage. Okay, that's been in for about 2 hours, so I'll take this out, give it a really good rinse, and then it's straight into the dye. Okay, I've got my black dye set up here, and I've heated this up to about 50 degrees centigrade, and we're about to dip the part, but I've been very, very careful about rinsing this. Often this threaded hole will hold a little bit of the acid from the anodising bath. If you don't rinse that out, it'll leach out of the hole and it won't dye in that area. So we'll try this now. Now often you see people on YouTube and they'll pull a part out after about 2 seconds and it looks like it's completely black. I'm here to tell you that almost never happens. This might take up to 15 to 20 minutes to take up that dye. Alright, that's been about 3 to 4 minutes, and you see it is starting to turn black, but it needs to be in there a lot longer to go that really dark, uniform black. Okay, that's been 15 minutes, that's the colour I want, so now this gets sealed in boiling water and that finishes the process. Okay, this takes about 10 minutes in boiling water. And yes, I'm doing this on the kitchen stove and I've got to get it done before my wife gets home. Here's a close-up look at all of the parts the next day. So these Parkerised parts are now dry-ish. They've still got an oil film, but the water has all gone out of that oil. And these powder-coated parts came out really, really good. The only thing I don't like here is that where I put the silicone plug, it's left a little raised burr around the edge there. You can sort of file it off or sand it off, but I don't think I'm too bothered about it. So what I'll do now is get all of this put together. I'll show you the finished product, all assembled, and we'll have a quick look at some of the functions of a float lock vise. Well, here it is, all put back together again. Went together really well. No real issues, although I did find that these two steel jaws here were now fairly tight on the steel bar. Now, somebody did ask me once before whether the Parkerising adds any thickness to the steel. At the time I said no, but now I've realised that if you've got a very, very tight tolerance, which I had, the Parkerising does tend to catch on that surface there. So all I had to do was go around the inside with a drum sander in a Dremel and take off the Parkerised coating, and it slid together really well. And while I was at it, I did this little V-block as well. Now this is the one that I made where I clamped it to the side of the drill press table and I used that as a drill guide. So the good thing about doing Parkerising is that you can do batches of parts, and even if you're not working on that project at the time, you can do the Parkerising, put it aside for future use, or if it's an existing tool that you've been using and you're finding it's going rusty, you can Parkerise it and it's done. So I'll put this aside. This will get used in the drill press and the milling machine at a later stage. Now that powder coat, by the way, the colour of that is called Jotun, J-O-T-U-N. Now this was sent to me by my mate Stuart. He's got a YouTube channel called Scrounger's Workshop. He does a lot of vice restoration and so on. But I love that colour, it's a really nice rich yellow. One other little refinement I made on this before I did the final assembly was the machine in this little V groove here. Now I found this detail on the original float lock vise drawings, and what it does is it gives you a visual indication of how much movement you have with the moving jaw before it reaches the end of its travel. So when you're setting up a part between the vise jaws there, you can tell whether you're going to be able to close the jaws up, and of course if you don't have the required amount of movement there, you can just ratchet that jaw up a bit closer. Now I also hardened and tempered this steel pin here. In its previous state it was soft. It is a water hardening steel, so I heated the end of that pin up cherry red and quenched that in water, making it fully hard. Then I was able to polish back the tip and heat it near the middle, and as the colours came up toward the working end I stopped at a sort of a medium straw colour, so that will give it a certain amount of toughness and wear resistance to allow it to do that ratcheting thing without wearing out the end of the pin. Now the other thing I didn't do, I didn't put any surface treatment on this steel bar here. Now it was awkward, it's very long, and if it gets annoying, if it goes rusty, what I may do is put a very light zinc plate coat on it. If I do anything with that, it's going to increase the diameter, like plating does add thickness to the metal. So does the Parkerising, and also just because of the sliding nature of the way it works, it would probably eventually wear through the coating. So at present it's just polished mild steel. I'll just have to do a bit of maintenance with that part of it, but yeah, it's just an awkward thing to do. Alright, what we need to do is go over to the drill press now. I'm going to set this up and show you two other features or two other applications with the float lock vise, and then we'll wind up. This is a really good example of how this stop system works. Now I've got to make 8 of these parts. These are made of a composite plastic material for an outdoor application, and I've got to make 80 of these, and they all need to have a single hole drilled in the center. So I've already set this up. I set the stop, and what you can do is place the part between the jaws there and just snug the jaws up so that the part's gripped there but it can still slide, so you can put them in and out really quickly, and then slide that up to the stop and just drill the hole. So let's do that one. So you get the idea, and what I'll do later on is reset the width of the jaws here for these narrower ones. So for me anyway, that's a really quick way of doing multiple parts. So here's another neat trick you can do with the float lock vise. So let's just say, for example, you want to drill a hole in a piece of thin sheet stock like this, and the risk always is that the drill bit will catch in the material and it will pull it up the drill bit or spin it around like a helicopter blade and cut your hands to ribbons. But with the float lock vise you can lift the vise off the drill press table and just tighten it down, and then you can drill between the vise jaws here, and because it's held down securely against the table and it can't lift, it's a much safer operation. So you get the idea, and you could use whatever size drill bit you want, and if you want to use that trick that I showed you about using a couple of folds of cloth between the drill bit and the sheet stock, that's even safer. Well, that's it guys. Thank you very much for watching today, and if you stuck with the whole series, thanks again for that as well. Now don't forget, you can get the drawings and the other resources from the folder on my Dropbox, and there's a link in the description below. If you do make one of these and you're proud of it, send me some photos. I'd love to see your version of this same tool. And this is going to prove to be a very useful tool in my workshop. I know Blondie Hacks loves the one that she has, and just with the little use that I've had with this already, I think it's going to be a fantastic addition. Now, I'm going to say goodbye at this point, but I'll leave you with some wildlife footage. The first of these is a little snake that popped up in our decorative pond at the back of the house, and then we're going to have a look at some big black cockatoos. Okay, it's Prezzo signing out. Thanks for watching. Cheers. I was cleaning the pond. This little keelback snake stuck his head out of the water. These things are quite harmless. They're not venomous at all. Apparently they're poisonous though. If anything eats one of these, they get quite sick. There's my feet just there. He wasn't far away when I spotted him. I'm not scared of snakes. Now, I just thought I'd finish up by showing this footage of these yellow-tailed black cockatoos that we saw on our morning walk. Now, we've seen these birds before. We think that there's a juvenile and 2 adults, and these are Australia's biggest species of cockatoo. They can be up to 65 centimetres long in the body, and they have these very impressive strong beaks. Now, they can use the beak to crack open very hard seed pods, but they'll also strip the bark off branches, and they will burrow in to find things like moth larvae and insects and borers and so on. But those beaks are so strong that they can snip those branches off, and you'll find them littering the ground underneath the trees where they're feeding. So it was a real treat to see them, and we don't see them around the house so much. They tend to be in the forest where they need cover, and yeah, it was just beautiful to see them. So enjoy.